All right, we are discussing another concept today, and that is the inverse functions. So for every function, we can also find the inverse of that function. Rightly, I discussed that in my video that had to do with domains and range and that. But I want to look at this in another perspective, where we have y equals to sine x. The inverse of this function is actually x equals to sine inverse of x, or what we say arc sine x. So you can write this, or you can write it this way. So this is sine y. Y. So the things you also notice, if we have y equals to cos x, you also have x to be equals to the cos inverse of y. Okay? And then we have e raised to the power of x equals to y. You also say that x in this case is going to be equals to log y, that is log to base e and y. This is not all I'm discussing today. What I want to discuss is how do we find their derivatives and how do we differentiate such function. So this is how we handle it. Remember from elementary trigonometry that sine square x plus cos square x is equals to 1. That can be proven with the basic idea of the Pythagoras theorem on right angle triangles or in a unit circle. Now from this you see that sine square x will be equals to 1 minus cos square x, and cos square x will be equals to 1 minus sine square x. So this can also be written as sine x equals to 1 the square root of 1 minus cos square x, and cos x can be written as the square root of 1 minus sine square x. Now with all this, and also let me call this equation 1, if we divide this by sine square x, or probably we divide it by cos square x, this is going to give us sine square x over cos square x plus cos square x divided by cos square x, and that is equals to 1 over cos square x. This is going to give us tan square x. 1 sine over cos is actually equals to sine theta over cos theta is actually equals to tan theta. So this is going to give us tan square x. Is going to give us 1. And the reciprocal of this basic ratio is actually cos sec square x. So take note. So I'm going to be using this, and I'm going to be using this also to do some derivation. The first derivation is we want to find out the derivative of sine inverse of x with respect to dx. So this is one of the things we are going to handle. We want to find the derivative of this. So how do we do that? Very easy. First note that x is equals to, let's take it from the beginning, y is equals to sine x, or sorry, sine inverse of x, because we are trying to find the y dx, so y is equals to sine inverse of x. And if that is true, we can rewrite this as x equals to sine y. X equals to sine y. And if x is equals to sine y, we can replace it with this formula. We can replace it with the formula, and this formula says sine, so I can replace this x with y. So it means that x will be equals to this sine y now will be the square root of 1 minus cos square y. So this is actually equals to this. Okay, so all we need to do now is to differentiate this. So I'm going to differentiate this now. So if I differentiate this, remember my video on differentiation. So if I differentiate this, I'm going to have dx dy, and the x dy is going to give us cos y. So if I differentiate this, I'm differentiating star, so it's going to give me cos y. And if it gives me cos y, you see that because if I replace this, I'm going to be having dx dy to be, so where I'm having cos y, I'm going to be using this. Just imagine this. Just imagine this. So I'm going to be having cos y to be the square root of 1 minus sine square y. Yeah. Now remember that sine y is actually equals to x. So if sine y is equals to x, it means that sine square y is going to be x squared. So this is going to be equals to 1 minus x squared. And remember, recall from my last video, recall that dy dx is actually equals to 1 divided by dx dy. Very interesting. Dy dx is actually equals to 1 all over dx dy. So that means my dy dx is going to be equals to 1 divided by dx dy. And the x dy is all this, which is this. That is 1 minus x squared. So that means anytime you are told to differentiate sine inverse of x, this is what you have. Now, I'm going to give you an assignment of trying the derivative of cos inverse of x respect to the x. If you follow this pattern clearly, what I have just done by making use of this, you are going to see that your dy dx, your dy dx is going to be equals to minus 1 all over square root of 1 minus x squared. Okay, now also let's rush over to that of tan. Very easy also. We know that we want to find derivative of tan inverse of x with respect to the x. How do we do that? Once again, you say y is equals to tan x, and if y is equals to tan x means that x is equals to tan inverse of x. Now, but remember that when you x is equals to tan inverse of y, I'm sorry for this, tan inverse of y. So, in the other hand, if we are given tan inverse of y, it means y is equals to tan inverse of x. And if that is true, it means x will be equals to tan y. Now, do you recall what is the derivative of tan y? The derivative of tan y, the x, the y, is equals to sec square y. Is equals to sec square y. And from here, you remember that sec square x is equals to tan square x plus 1. So if I replace that here, I'm going to be having 1 plus tan square y. And recall that x is equals to tan y. It means that tan square y will be equals to x squared. So this will be the same thing as 1 plus x squared. And from there, you can see clearly that from here, you remember what I said here. So applying this, you will see that dy dx will be equals to 1 divided by dx dy. Remember that this is the x dy. This is the x dy, so I'm going to put that for this. The x dy is 1 plus x squared. So that, again, you see that whenever you have the derivative of tan inverse of x, the derivative is simply the y dx, which is 1 over 1 plus x squared. Now I have just 1 minute left. I'm going to show you that of link x. So I will use that 1 minute to explain the x. So we start the timing, very simple. So if in this case y is equals to ln x, and we want to find the derivative of the x, very simple. From here, x is equals to e raised to the power of y, and what is the x dy here? The x dy is the same thing as e raised to the power of y, and I discussed this in my last video. So the x dy is the same thing as this, and if that is true, you can see that our dy dx is simply 1 over the x dy. And if that is true, we have 1 all over, what is the x dy? The x dy is e raised to the power of y. And remember that e raised to the power of y was simply x in the beginning. So meaning that our dy dx for ln x is simply 1 all over x. So in this video, I have shown you how you can find the derivative of 3 special inverse functions: tan x, cos x, sin x, and ln x. I'll be applying this in some of my integral video. Thank you. Remember to subscribe.